Hi folks, it's Friday on week 1 of term 2, and today your little exercise here is another one on algebra, and it's adding and subtracting like terms. Sorry, adding and subtracting terms. So the first thing we need to look at is that idea there of like terms. So like terms are basically anything with the same letters at the end. Okay, and the letters can be in any order. Because don't forget, this really is saying 5 times y plus 6 times y. Okay, now when we speak about kind of objects, we don't say, can you pass me 5 times forks, please? We say, can you pass me 5 forks? So if y was a fork, we would say, how many forks are there? 5 forks. So you can see that we don't really use the word times in there because even though it's a mathematical function, when we kind of translate it to just simple English, we don't say the word times in there. All right, so in algebra, we don't use the word times in there. We just simply put these terms right next to each other, and it means that the mathematical function is multiplication. Now, we don't know what y is, so we just go, there's 5 y's plus 6 y's. So if I have 5 y's and 6 y's, altogether, you can do it. Basically, you just add these numbers at the front here. So you go 5 plus 6. All right, down here, you've got DEF and you've got DEF. So those there are like terms, okay? So that there is the term, the whole group of letters and numbers. And you can see because the letters are the same here, all right, that means that that term is the same as that. I've got 6 of them here and I've got 6 of them here. And what's my mathematical function is subtracting. So if I have 6 and I take 6 away, well, you can do what's happening there. It doesn't matter what's going on to the term itself as long as they both are the same. So this one here, for example, I've got n times itself plus 3 lots of n times itself. Okay, because that there n squared and n squared is the same, I can add that. Now, how many n squareds do I have there? Well, once again, we don't walk up and say, can I have 1 iPhone, please? You say, can I have an iPhone? Okay, or pass me your iPhone. You don't say, pass me your 1 iPhone. So in mathematics, a bit like the way that we speak, we don't actually put the number 1 in front of it. So there's 1 n there plus another 3. So 1n squared plus another 3n squared. So that there would be 4n squareds all up. So there you can see we're simplifying each algebraic expression. Now, simplify is an interesting word. We're not solving it, okay, like we were yesterday in our work. That term there from yesterday was finding a solution, okay. So we were actually looking for a number in there, for like doing a solution there, like what's the actual answer. Okay, so down here, it just says simplify. So you might come up with still an algebraic term, which won't actually have like an actual answer. All right, unless we substitute a number in and we're working with just numbers, you will always see the word simplify because it means that there's still one function left. So you might have only one term there. So for example, this one here we had n squared plus 3n squared. Well, that would equal 4n squared. Now you've only simplified that because technically you're going 4 times whatever number is in there times itself. Okay, and you haven't actually solved it. Make sure you look above and see example 6 if you're not quite understanding that one. So simplifying the algebraic expression again, it says here by collecting like terms. All right, so this one here, you may or may not have like terms in here. So for example, we've got FGs, FGs, and FGs. So we simply go 2 plus 3 minus 4. Okay, and make sure that you put the FG there at the end. So don't just put your number down. You must include what you're talking about. All right, so I had $2 and my friend gave me an extra $3, but then I went to the canteen and spent $4 or FGs. How many dollars do I have left? So it doesn't matter. You can substitute any object in there if you're finding it hard, as long as each of the terms are the same, okay? When you've got different terms, you just kind of have to group the ones that are the same or the like terms together. So if I have 3x's plus 2y's plus 8y's, let's say I had 3 dogs plus 2 cats and someone else gave me 8 more cats. All right, well, apart from having way too many cats in your life, the 3 dogs can't be added to the cats because dogs aren't cats, okay? Dogs are way cooler. So you're still going to keep your 3 dogs, but how many cats do I have in total? All right, that's what you would have to work out there. Okay, the tricky one comes. Here's the tricky one down here in Q. This one here is 2L squared plus 2L. Now, L squared is not the same as L. For example, if I made this L here worth 3, I'd have 3 times 3, which is 6. Okay, but this one here would only be 3. And you know that 6 is not 3. So basically, if this is L squared, you have to look for L squareds as well. So I've got 2 L squareds and I've got 3 L squareds here. So I can put those 2 together because they're like terms. Then I've got 2 L's here and I've got 6 L's. Now, here comes the hard part. I've got 2 L's and I've got 3 L's, but see this plus sign here? I want you to circle around that. So that whole term there is plus 3L. So I'd go 2L squared plus 3L squared. Well, that equals 5L squared. Here I've got 2L squared, and it's positive, and I've got minus 6L. So 2L minus 6L. So if I have 2 and I take 6 away from it, I get negative 4. So I end up with 5L squareds minus 4Ls. If you're not sure on that one, I'll try and do a bit more of a written explanation for that if people are having trouble with that. Okay, but basically what you have to do is you have to group these terms together, and when you move this term, take the positive or the negative in front of it there. Okay, lots of people forget that. They just go, oh, that must be positive and that must be positive. No, that's negative 6L. That's positive 3L squared. All right, and you can work through some others. There's another tricky one up there. Sometimes you might just have whole numbers, and once again, that whole number takes that term there. So this is 2n, and we get minus 12n's. So I start with 2 and I take 12 away from that. And here, I don't start with 3 and add 5. I actually start with negative 3 and I add 5 to that. Okay, so it's minus 3 plus an extra 5. Okay, so this one here, you've got lots of different terms in here. Okay, so you've got one question here and you have to decide what the right answer is. Okay, so here we go. So you've got 15a squareds plus 12a's plus 48 minus 18a's. So what you would do is you would look at this term here at the back and go, which ones are the same? Okay, how many different a squareds have we got? How many different whole numbers? And here's a tip for you. If you look at all the a squareds and there's only one of them, then that term must appear in your answer somewhere. All right, if you've got whole numbers and there's only one of them, then that must appear in your answer somewhere as well. So use those there to help you out. This one here is in the quiz. Righto, this one here is determining whether this can actually be true. Can this equation actually exist if A is 2, B is 3, and C is 4? So we're combining this one here, okay, with our substitution. That means replacing a letter for an actual number. And then we've got to see whether the equation actually is balanced, whether this side here actually works out to be the same as that. So, for example, our first one here, we'd have 20C's minus 12C's should equal 8C's, okay? So a C is worth 4. So we go 20 times 4 minus 12 times 4 should equal 8 times 4. So you can just substitute those numbers in there and then do this function here, which is a subtraction. Okay, this one here, does 9b plus an extra b equal 9b times itself there? So b is 3, so is 3 times 9 plus an extra 3, the same as 9, all right, times 3 times 3. So you'd have to work that one out there and determine whether it is correct or it isn't correct. Okay, if it's correct, you can tick it, all right, or say, yes, it's correct. If it's not correct, in other words, if the number on this side of the equal sign is different to the number on the other side of the equal sign, then it doesn't work, all right? It's definitely an incorrect answer there. All right, work through some of these. You simply substitute them in and then do your little functions, okay? Don't forget that 2 in here is a times, so you have to do that by itself. Sometimes what I do when I'm starting to do these basic kind of substitutions is like this kind of, use a set of brackets in there, all right, to represent 2c. So put a bracket around in front and go 2 times, well, c here is 4, and close the brackets. That helps me because then I can use my bid mass, that brackets, indices, divide, multiply, and then addition and subtraction, all right, to work through the actual problem there. All right, so this one here is saying 2c minus b plus 3b's minus another c should equal c plus 2b. All right, so substitute in your numbers, and then you should end up with a number on this side of the equal sign, a number on that side. If it's the same, then that's correct. If it's different on either side, then that is an incorrect equation there. All right, good luck with that today. If you have any questions, don't forget mathsisfun.com is a great website. You can go on to Mathletics, log in, and at the top right-hand corner of Mathletics, you can see it will teach you the actual thing that you're doing there. I might do a quick short video on that so you guys can learn how to use Mathletics to the best that it has there for you.